Hi, welcome to Unit 10, Day 4. Today we're going to start looking at three-dimensional shapes with surface area and volume of prisms and cylinders. A prism, you may recall, is a three-dimensional shape with two parallel bases connected by rectangular sides. So the sides will always be rectangles. So if you ever have any shape that's not a rectangle, that's going to be one of your bases. So it's super important to remember that you're going to have two parallel bases. I should highlight that. Two parallel bases, and they will be connected by rectangular sides. So anything that's not a rectangle is going to be a base. Okay? Prisms are named by their bases, and the height is the distance between the two bases. So when I'm looking at this first set of pictures, and it says to name each prism and label the height, when I look at this, I'm going to say, okay, I can see this shape here, and it definitely has this side here that is not a rectangle. So this is not one of the sides. This is definitely a base, and it has 1, 2, 3, 4, 5 sides. So that's a pentagon. We call this a pentagonal prism. Pentagonal prism. And when we label our height, I'm going to label the height in, what's that color that'll show up on all of my pictures? Let's go with this bright green. I'll make it nice and thick here. My height, so from one base to the other base, all of these distances right here, that is my height, H. Okay? When I look at this next figure, all of the sides are rectangles, which means we kind of get to pick here which one we want to be our base. So when I just look at this figure and if I go, I'm just going to pick one for the base, a lot of times if all my sides are rectangles, I'll just go with whatever's on the bottom. That's the rectangle I'm going to say is my base. Now, since the shape of the base is and I'm actually I didn't do it in the last one, but I'm going to highlight both of the bases in each picture. So I've got a base, that's a pentagon, and its parallel bases down here. My two parallel pentagons. And so then on this one, if this is my base, then the matching one, the parallel one, is up here, because then what that's going to do is that's going to make it a lot easier for me to label my height. From one base to the other base, there is the height. Okay, and then to name this shape, I'm going to say, well, if my base is a rectangle, we're going to call it a rectangular prism. Okay, all right, when I look at this next shape, I see along the bottom, I do have a rectangle here, but there's not a parallel rectangle anywhere above it. The other two rectangles both intersect it, but I do see that I have a shape that's not a rectangle. I have this triangle. That triangle, even though this is on its side, that is considered the base. Notice there's two of them, and they're parallel to each other. One's in the front closer to us, and the other is in the back further away from us. Okay, so those are my parallel bases. My triangular shape has just been laid down on its side. My height then is still the distance between the two bases. So from one base to the other base, this distance right here is going to be the height. So that's what I'm going to label with H for the height. And then what I'm going to call this figure is my bases are triangles, so it's a triangular prism. Okay, let's look at the last one. On the last one, again, it has this rectangle that it's sitting on the bottom, but I see it has shapes that are not rectangles, so those have to be my bases. If you have shapes that are not rectangles, those have to be your bases. So how many sides do they have? 1, 2, 3, 4, 5, 6, and the matching base is over here. 1, 2, 3, 4, 5, 6. So there's 6 sides, which means the bases are hexagons. And then my height is the distance from one hexagon to the other hexagon. Okay, and I know it looks really weird the way I've got it kind of drawn here, but all the heights are really going to be the same because this one here really goes to, it stops there, and then this one goes all the way to there. Okay, so all the heights are the same in my shape. So my height is the distance from one base to the other. It's not necessarily how tall it is standing up, right? Because this is laying on its side. And then we call this, since its base is a hexagon, we call it a hexagonal prism. Okay, in addition to prism, today we're also going to look at cylinders. A cylinder is similar to a prism, but your base is going to be a circle every single time. It's going to look like when you're standing up 3D, it's going to look like it's an ovular. That's not a word. It's going to look like an oval as opposed to like a circle. But if you were to take a can opener to this, if this was a can, and take the top and the bottom off, you'd have a circle on the top, a circle on the bottom, and then if you stretched out that piece of metal in the middle, it would make a rectangle. Okay, so it's similar to a prism, but the bases are circular. And then if your side is flattened out, it makes a rectangle. Your height is still the distance between the bases, which are now always going to be a circle. Okay, there are 2 types of area we're going to talk about when we're doing prisms and cylinders. The first one is our lateral surface area, and that's everything that's on the sides. So it's all of those rectangles put together. So up here, all the rectangles, not the pentagon. Here, 4 of the rectangles, not the 2 base rectangles. Here, the 3 rectangles, not the 2 triangles. Here, the 6 rectangles, not the 2 hexagons. And here, the rectangle, not the circles. That's your lateral surface area. Think about if you're putting a label on a can, that's your lateral surface area. Your total surface area is the same thing, but with the 2 bases. Okay, so then we're going to include the tops and the bottoms in my total surface area. Sometimes you will come across a problem that doesn't specify if it's asking you for the lateral or the total surface area. When that happens, we always go with the total surface area. So if it's not specified which type of area we're looking at, we always use the total surface area. Okay, let's look at the formulas that we're going to be using today. The following formulas can be used to find the lateral surface areas, which we're going to use an L for, and the total surface area, which we'll use an S for, and the volume, which we'll use a V for prisms and cylinders. And notice they're capital L's, capital S's, and capital V's, and the capitals really do come into play when you're working with area and volume. Okay, so my formulas. For prism, we have the lateral area of a prism, so just the sides, not the bases, is the perimeter of the base. P stands for the perimeter of one base, times the H, and that's the height between the bases, which can sometimes get confusing because some of our bases have heights. For example, think about if you're doing a base that's a triangle, the formula for its area is 1/2 its base times its height. That height of that triangle and the height in this formula are 2 different heights, but you might end up using them both in the one problem. Because when you do the total surface area, S, it's that pH, the lateral area, the sides, plus then we're going to add those 2 bases on, right? So when you add the bases on, then you're going to be dealing with the height of the prism and possibly also the height of the base. So you'll have to really keep those separate, okay? And then volume here also, my volume for a prism is 1/2 the area of the base, capital B, area of one base, times the height of the prism. Okay, so the area of the base, which might have its own height, times the height of the prism between the bases, which will be different than the one here. Okay, your cylinder, it's really nice because they always have circular bases. So it's 2 pi RH for the lateral area, which if you think about it, the perimeter of a cylinder is the circumference, 2 pi r. So it's really still the perimeter times the height. The total surface area is the perimeter times the height plus 2 bases. But if it's a circle base, my bases, the area of the base is pi r squared. So we just substitute that in. And then the volume is pi r squared h because the area of a circle is pi r squared. So the cylinder's formulas are the same as the prism formulas. We just happen to know what the base is every time. So when we talk about the perimeter, we know that's the circumference, 2 pi r. When we talk about the base, we know that's the area of a circle, pi r squared. Whereas with a prism, because our bases are going to change, the perimeters will change, how many sides you're going to be adding together, and the area of the base formula may change, depending on if it's a hexagon or a triangle or a rectangle. Okay, go ahead and come on back for the next video and we'll actually apply these formulas to find lateral areas, surface areas, and volumes. Thank you so much for watching.